Okay, we are live. So we are going to talk about inequalities, solving them, and graphing them. Up to this point, all we've talked about is equations, where this equals this. There's only one answer, right? X is equal to 10, right? Or as they said in that cartoon, whoa, hold on just 1 minute. Yesterday said X equals 3, right? X changes, right? Depends on what equation I give you, right? And you solve for X, and X is one answer. Very simple, right? However, there are many times in math and in life when it's not X equals one thing, but X could equal lots of things, right? Like you can drive as long as you are older. You are, you're. Let's see, what is it? I think
it's
you can.
16.
You can. I think in this town, I think 15 or older, right?
It's 15 and a half.
15 and a half or older. So if I was making X the number of the required age, right? Or all the possibilities of ages that you could actually drive, right? Okay, Emily, right? If I want to know X was all the possible ages that you could be to drive, well, X, I can't just say equals. Who's talking? Somebody's talking. Gabe, what's up? What? Nothing? Okay, so I can't just say 15 and a half, right? Because what about people that are 17? Can they drive? Yeah. What about people that are 92, right? They can drive. What about people young like me, who 56, right? We can drive, right? Super young, right? So what would I have to have a different symbol? I can't just say X equals 15.5. I need something else. So what would I use? Yes, Graham. Greater than, right. So I could say X is greater than 15.5. Now, the only thing is, but what if I was exactly 15.5?
Oh, you put a line over it?
Yeah, I would. It's so there's greater than or equal to. So we're going to talk about these symbols right here. All right? So we're going to sort of identify them first. We're going to figure out what they're called. So this is that means greater than.
Alligator eats the bigger number.
Greater than. Yep. This means greater than or equal to. Greater than, if you have that line, just like an equal sign, half of an equal sign, it also means it equals that, right? Greater than or equal to. All right? And then we have these. And notice it's always going from the left to the right. When it's like if I went from left to the right, see that big mouth of the alligator? Right? This is the big mouth of the alligator, right? Here's his eye, right? So the big mouth is the bigger side, right? As I'm going left to right. So it means bigger than or greater than this tiny little dot right here that's something else, right? It's going to be bigger, less than, whatever. That's the bigger side, that's the smaller side. But here, as I go left to right, I hit the little teeny point first. That means that's the little side. So this side's the littler than this side, right?
Yes.
So this means less than. And then this means less than or equal to, right? Now, how many people have learned this already? I just want to know. Not, okay, it looks like everybody has, right? Everybody has. That's awesome. Less than or equal to, that's good. That's fabulous. So it's not a brand new concept for you. That's awesome. So that means if I said, what would I have to put to make, which one of these signs would I put to make this correct?
Oh,
Less than.
Less than, this one, right? So you're saying 8 is less than 10. That's
Yes.
correct. How could I rewrite this with a greater than sign?
10 is greater than 8.
All right, so look, I can flip them as long as the mouth flips too. The mouth has to flip. The alligator mouth, it's facing the 10. It's got to face the 10, which now means greater than 8. Right? Make sense?
Yes.
All right? And so, all right, so that's that. Now, let's talk. Now that we have those, can I erase this?
Yes.
Just so that I have some space. I think first we're going to talk about solving. Solving them algebraically. Solving inequalities algebraically. All right, so that's what we're going to first talk about. Okay. You solve them exactly like equations. Now, I realize I shouldn't use the word exactly, but I am anyway. Like equations, comma, with two exceptions. Here's the first one. If when I'm solving it, I multiply both sides of the inequality by a negative number. If multiply both sides by a negative number, the inequality sign flips. The inequality sign flips. And we're going to go over that in a second, but I want to finish the notes here for this. I'll show you examples. And then it says, if you divide both sides by a negative number, the inequality sign flips. Now my guess is none of you have done this.
Which one?
Either of these. My guess is none of you have been exposed to
I've done
this.
the top one.
This one?
Yeah, but it was a while ago.
It was a while ago. Okay. All right. So, when you're solving inequalities, you have to keep in your brain this like ultra-sensitive sonar radar device that goes off, like huge in your brain that says, oh my gosh, I'm dividing by a negative number, or I'm multiplying by a negative number on both sides. I'm going to have to flip my whatever it is, inequality sign, right? To the other way. All right, so how far can I go? I can go there. Okay, so let's try an example. Example of number 1. All right, so let's say I had, this, negative, hang on, let me just think about this for a second. Yeah, okay, how about this? Negative 1/3 x equals 10. Negative 1/3 x equals 10. I want to know what x is, right? I don't want to know what negative 1/3 x is. I want to know what x is. So how do I get rid of the negative, first of all? Well, I could add this to this side, and then I have 0 is equal to 10 plus 1/3
You would
x.
just multiply each side by a negative number or something.
So yeah, what could I
Negative
multiply
1.
this by to
Negative
make
1.
that equal 1?
3 over 1.
Negative 3 over 1. See how that would turn that into a positive 1? You see that? I'm just multiplying by a negative reciprocal, right? And so that means on this side I'm going to multiply it by negative 3 over 1, which is the same as negative 3. So suddenly, oh my gosh! My brain! I remember! I'm multiplying by a negative. Both sides by a negative, right? Then that, oh, not equals, sorry. I forgot what I was doing. We'll say it's greater than. Sorry about that. So change that on your notes. I didn't mean to put an equal sign there. So that means now, I'm going to multiply this out. Negative times negative is positive. The 3's cross out, the 1's cross out. It's positive, so it's just x. And over here, it's 10 times negative 3 is negative 30, right? But what do I have to do with this? I just multiplied by a negative number, both sides. That, now the point is pointing to the right, and now it's got to point to the left, right? There we go. Right?
Yeah.
Make sense?
Yes.
And I'll show you why this is true. Let me think. How can I do this? All right. So somebody suggested something. This is the shortcut, right? That's the shortcut. Somebody suggested, well, we said negative 1/3 x is greater than 10, right? And we're going to now do it adding and subtracting. If you add or subtract both sides, the sign does not flip. It's only when you multiply or divide, okay? It's okay to subtract things from both sides. You've still got negatives, right? But you're just subtracting them. You're not multiplying or dividing by a negative number. So if I just add 1/3 x to both sides, look at this. Then I would have 0 on this side, right? Is greater than 10 plus 1/3 x, right? But I want to know what 1/3 x is. I want to isolate the x's, get rid of this 10. So now I'm going to subtract 10 from both sides. Look at this. So I have negative 10 is greater than, I didn't multiply or divide, so I'm only adding and subtracting. The sign stays the same, right? Equals positive 1/3 x. Oh, well, I can multiply this times 3 over 1, right? And that becomes 1x. Multiply this times 3. So all I have really is negative 30 is greater than x. What did I get? Where's my answer? X, negative 30 is bigger than x, right? Or x is less than negative 30. X is less than, if I read it from the right to the left. You see what I'm doing?
Yeah.
X is smaller than, because the point's facing the x, negative 30. You get it? Make sense? All right, so that's one. So that's why when you add it, it's got to be the same as when you use your shortcut. And they found, oh my gosh, using our shortcut, whenever we multiplied by a negative number, we got the wrong sign. So they learned they had to flip it, right? Because they knew this was legal. They weren't sure about this. And that's when mathematicians realized, well, I know that's right, so we have to flip it whenever we multiply both sides by negative. Same thing is true when you're dividing. Can I erase this?
Yes.
God, get it from your neighbor. Because, sorry. I realize I'm in your way.
I don't have that either.
What?
I was still right.
I know, but he has it, right? Can you just finish it? Which part were you at?
I was just at the end bit where you're multiplying 3 times negative
3 times, down here?
10. Yeah.
Right, so it was 3 times negative 10, so it was,
Negative 3.
so negative 30 is greater than x,
Yeah.
right? All right, sorry about that, buddy. I forget because you're in the worst spot because I tend to write with my right hand, so you miss it. Sometimes I'll try to do it so you can see it this time. So this one though, an example of this would be if we divide both sides. Let's say had negative, well let's do something like this. Let's say 2 minus 2x equals 10. How would I solve this? Oh, not equals. Keep doing that. We'll do less than or equal to. So how would I solve that? I want my x's all by themselves. What's in the way?
The 2.
The 2. So that's a positive 2. So how do I get rid of it? Subtract 2. Subtract 2. All right. This is a negative, but I only subtracted. I didn't divide. So this still stays the same, right? So now I have just negative 2x is less than or equal to 8. Now what do I do?
You would divide on both sides. Yeah, you divide negative 2.
Divide by negative 2, because I want this to be 1, and negative 2 over negative 2 is 1, so that's good. Divide by negative 2. Oh my gosh, I divided by a negative number. So x is now not less than, x is greater than or equal to negative 4. Make sense? All right, so we're going to do a couple. Can I erase this stuff now that you guys have it in?
Yes.
Do you have this now? You get that?
Not that problem, but
Not that problem. So I'll just erase the rest. Is that okay?
yeah.
All this stuff. All right. All right. So we already talked about that. So let's try a few just to get used to it. How about okay. 4 plus 6x equals 64.
Subtract 4 from both
Subtract 4 from both sides. Subtract 4. Because I want my x's isolated, all by themselves. That gives me 6x is equal to 60.
Yeah, did you mean put equals?
I keep doing equals. I can't seem to get that in my head. Sorry, guys. I'm so used to it. Okay. I apologize. Thank you for finding this. Catching
X
this.
is equal to 10.
Not equals. Don't let me do any more equals. Okay. So 6x is greater than 60. What do I do? Divide by 6. Divide by 6. X. Do I flip the sign? Do I flip this now?
No.
It's not a negative.
Oh, you're right. It's not a negative. Okay. So the sign stays the same. X is greater than 10.
Oh, that's pretty easy.
All right. Now, while we do these, I'm actually going to show you the graphing part too. Okay. So make sure you've written this down because now we're going to graph it. Graphing is easy. Easy peasy. All right. With this kind of graphing, usually it's just a straight line. All right? And I notice that x is greater than 10. So that tells me here's 0, and somewhere over here is 10. I don't have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? I don't need to do that. I can just say 0, 10. If it was negative 10, it would be 0, negative 10, right?
Oh yeah.
Right?
And then you
Yes.
circle the. Well, wait. Then you circle 11 and draw an arrow to the right.
No, you just circle
Not
10,
quite.
leave it blank, and then draw an arrow up and draw it all the way over.
So there's 2 ways to circle, okay? One is a solid circle, and one is an open circle, all right? So you have to think about which one is. So you've got a solid circle like this, a solid dot basically. Solid, that means what that solid means it equals that point. Or it includes that point. It includes, we'll say that. Includes, looks like a C. Gosh, includes the point. Okay. An open circle, it means that it starts but does not include. Starts there but does not include. Starts there but does not include. Whoops, include. Gosh. Include. Okay, point. All right. So the way I think about it is solid dot, it's touching the point, right? An open circle is around the point. It doesn't ever touch that point. Does that make sense?
Yes.
Right? So that open circle never touches this point. Now, is it an equal sign? Is it greater than or equal to?
No.
No. It's just greater than. Meaning it starts at 10. Like 10.00000000000000001 is a solution, right? So I can't just jump to 11 because 11 is, I mean, there's all these points. There's an infinite number of points between 10 and 11 that would be included, right? So you have put an open circle around there, right? At 10, an open circle. Do you see that, Henry? Does that make sense? Open circle, it doesn't touch the point. But that it shows you where the point where it begins, right? Everything that's bigger than that, you make a big solid line, sort of like that, and then put an arrow. That's how you graph those. Piece of cake. So let's practice a little bit of graphing for just a second, and then we'll do some more of these and graph them. So let's try this one. Let's graph. X is less than negative 16. X is less than negative 16, so write this down in your notes. You're going to just draw your line. Here's negative 16 is on the left side, right?
Yeah.
So that's negative 16. Here's 0. All right, but it says X is less than. Where is it less than? Here or here?
To the left.
To the left. Okay. Does it include this point?
No.
Yeah.
No.
No. The only time it includes it is if there was a straight line underneath it. So it's going to start at negative 16, and it's going to be less than. It's going to go this way, and you put your arrow. Pretty easy, right?
Yeah.
All right. So what about this? What if we had X is greater than or equal to 42? All right. So here's my line. Here's my 0. Here's my 42. What would I do?
Fill in the dot at 42 and then go.
It's a solid dot this time, right? Because it equals that point. It includes this point, right? But it also equals above that point. It goes above that point. So it's going to be X is greater than and equal to 42. You get that? Make sense? Okay, pretty straightforward, right? Pretty easy. Fist to 5, 10, fist to 5. Fist to 10. So, yeah, good. Everybody's getting it.
6.
All right, so let's try a few more. So, I'm doing, okay. So let's try, oh la la. Okay, so we'll make it, okay, 5 minus 4/7 X equals,
But not equals.
thank you, is less than or equal to 1/7 X plus 10. I don't have any idea what this is going to look like, but we'll just try it. What would I do first? I noticed that there are x's on both sides of the inequality sign. Big problem. You're never going to solve this until you deal with that. Hayden, what would you do?
You would subtract 1/7 X for both sides.
Notice he's not looking at the 5 and the 10 first, right? He's looking at his x's first. That's what he's going to get together first, right? So he's going to subtract 1/7. What did you just say? Is that what you said?
Yeah.
Subtract 1/7 X from both sides. Subtract 1/7 X from both sides. So we have now 5 minus, what's 4/7? What is negative 4/7 minus 1/7?
5/7.
Negative 5/7, right? They're both negative, so you're always going to the left. So you're always going to add them together. Negative 5/7 X is less than or equal to, because the sign didn't change because I didn't multiply or divide by negative. I just subtracted. Less than 10, right? Less than or equal to 10. Now what would I do? What's the next thing? I noticed that all my x's are on one side. That's good.
Subtract 5.
Subtract. Is that what you're going to say, Lucinda? Subtract 5. Subtract 5. Okay, I still didn't do anything that's going to make me have to change my inequality sign. So now I have negative 5/7 x is less than or equal to 5. All right, that's amazing. I can't believe I did this. It's going to work. Okay, it's not even going to be a fraction. It's so cool. All right, so now what I do? I've got this mess here. Negative 5/7 x. I want to know what x is.
Negative 7/5 multiplied.
All right, so I multiply by its reciprocal, and if it's negative, it's got to be negative. The reciprocal's got to be negative as well. So negative 7/5, right? And this is 5/1. I'm going to make that 5/1 because I'm going to be multiplying by a fraction by negative 7/5, right? Okay, so the negatives become positive. Negative times negative is positive here. The 7s cross out, the 5s cross out, it leaves me an x. X is now, but I multiplied both sides by a negative number, right? By negative 7/5. So what do I have to do here?
X is greater than.
It's going to be greater than now. The point is going to be facing the other direction. And then look, the 5s cross out.
7.
So it gives me negative 7. Negative 7. X is greater than or equal to negative 7. Okay? Now to graph it, here's my 0. Here's my negative 7. What do I put here? Solid or open dot?
Solid.
Solid dot. And x is greater than that point. That's bigger is on this side. So I go this way and I put my arrow. Pretty straightforward, right?
Yeah.
Can we start on our homework?
No.
And then the last thing,
Not 52. Really.
sometimes, just for graphing, so you got the idea. So for graphing, sometimes you'll see this. You'll see they'll put an x in the middle and they'll go like this.
What?
Yeah, I know.
Okay? So let's look at that. The way you read this, you could read it like 4 is less than or equal to x, which is less than 17. That's not the easy way to read it. The easy way is to start with the x, and you read backwards, and then you read forwards from the x. So really, even though that is a less than or equal sign, if I'm reading backwards, wouldn't you say x is greater than? Right? Because the big mouth is facing the x, right? X is bigger than or equal to 4 and less than 17. Does that make sense?
Oh!
Right? So x is greater than 4, but less than 17. So the way you graph that, all right, here's 4. I don't need a 0. Here's 17. X is everything in between, right? But what do I have? What do I put here?
Dot.
A solid dot, right? X is greater than or equal to 4. And then what do I put here?
No.
So, Henry, you seen this? Sorry, I keep covering it up for you. This is going to be an open circle. So x is greater than 4 and less than 17. So it's just going to be a big fat line between those 2 points. Does that make sense?
Yeah.
You get it? Fist of 5? You guys rock. All right. So, yeah, so we're not going to do this today. Tomorrow we'll probably get into this. This is the fun stuff. Now notice these so far, there's only one variable, right? There's only an x, okay? Eventually, maybe tomorrow, we'll get into these where it's actually x and y, where if it's an x and a y, I have to use a coordinate plane, right? I have to have an x and a y axis, right? Here, I only have one axis. I'm using my x-axis, right? Piece of cake, right? So these are single variable inequalities. And eventually, maybe tomorrow, we'll do 2 inequalities, right? So, okay, that's it. So that's the end of the lecture.